Good day. My name is Lorenzo Rafael Aronga from 12 STEM 1. I will now present my research study in partial fulfillment of requirements in practical research 2. The coronavirus have first emerged in Wuhan, China on late December 2019. Within a few months, the virus has rapidly spread to other countries, which then brought a calamity to the world. As of May 2021, the coronavirus cases in the Philippines reached more than 1,113,000 cases. The death toll have tallied 18,620 deaths, and the number of recoveries amounts to 1,038,000. To this day, the coronavirus cases are still increasing. Fortunately, the vaccine is already made available for the public. There are already 2.54 million dosages given. 517,000 people are fully vaccinated. Comparing to the whole population of the country, it has already reached 0.5% of people who are fully vaccinated. Given more time, the vaccine will be able to reach the masses. But until then, we will continue to implement the non-medical interventions to mitigate the spread of coronavirus. Social distancing is one of these non-medical interventions. It is a public health measure that aims to lessen physical contact. This includes remaining out of congregate settings, avoiding mass gatherings, and more importantly, maintaining distance of approximately 1 to 2 meters from others when possible. Social distancing is one of the most effective interventions to slow down the spread of coronavirus. However, many people are not following social distancing properly. According to an article of CNN Philippines on April 2021, the non-observance of social distancing netted 4,740 violators, while 341 offenders were reported in mass gatherings. With the growing concern of the lack of implementation of social distancing, the researcher has come up with a device to properly and efficiently uphold social distancing. Arduino Uno is a microcontroller which has been already used by many researchers to solve environmental and health issues. That being said, we will be using Arduino Uno to help us solve the lack of implementation of social distancing. Social distancing involves measuring the approximate distance between yourself and the person in front of you. Most of the time, the distance is not always consistent if you only visually estimate the distance. With the assistance of sonar technology, we can create a device to maintain the 1 to 2 meter distance between individuals. The ultrasonic sensor is a sonar technology which is said to be cheap and robust to environmental changes. This sensor will become a main component of the device. Using Arduino Uno and ultrasonic sensor, we can make a device that will assist in upholding social distancing and help us get through the crisis of the pandemic. Panelists, I present to you my study entitled Arduino Perimeter Alarm System for Social Distancing. The objectives of the study. The objectives of the study is constructing a wearable device equipped with an alarm system for social distancing. In this study, we will be answering the following questions. Number 1, is the device efficient in keeping a distance of 1 meter for social distancing? Number 2, is the device functional in giving feedback to the user through light and sound signals? And number 3, what is the end user acceptability of the device in terms of cost, design, portability, ease of use, marketability, and relevance. Hypothesis. The null hypothesis is that the device is not efficient in keeping the 1 meter social distancing and giving response to the user. The alternative hypothesis is that the device is efficient in keeping the 1 meter social distancing and giving response to the user. This study is expected to A. Produce an alarm system for social distancing that is functional and easy to use. B. Make the device effective for social distancing. And letter C. Make the device acceptable and pleasing for the user. The significance of the study. The device is beneficial to the frontliners and people who are at a greater risk of contracting COVID-19. With the assistance of the device, the chances of contact with other individuals will decrease, which will proportionally diminish the chances of infection of COVID-19. The device will also help the public health workers and law enforcers who are mitigating the spread of the disease. The scope and the limitation of the study. This study focuses mainly on constructing a device embedded with alarm system for social distancing. The device will notify the user to keep a 1 meter distance from others. Once a person enters inside the 1 meter perimeter, the alarm signal will start emitting light signals. After 10 seconds, the buzzer signal will trigger. It will continue to activate until their people are exits the vicinity. However, the efficiency of the device as an alarm system is only applicable to the isolated use and conditions which the testing was conducted. Risk assessment. The researcher will be observing the proper safety precautions before, during, and after the research implementation. The researcher will be handling electrical components and solder. The researcher will be using gloves to avoid minor injuries. The researcher will also observe proper waste disposal. The conceptual framework using the IVDV model, the independent variable being the device, Arduino perimeter alarm system, and the dependent variable is the functionality of the device in terms of A. Keeping the distance of 1 meter, B. Accuracy of distance measured, and C. User feedback through light and sound signals. Letter D. Ease of use. The methodology of the study will be using this flowchart. The flowchart will start with the acquisition of the materials. The materials of the device will be using the following: Arduino Uno, ultrasonic sensor, buzzer, light emitting diodes, 9-volt battery, and jumper wires. The next part is the design and layout of the device. The device is designed to be compact and light. The materials will be fitted into a light cardboard chassis. The device will be secured on a lanyard for it to wear at chest level of the user. The ultrasonic sensor will be placed at the front so that the sensor will function. When a person enters at the vicinity of 1 meter of the user, the device is expected to light up. When the user or the person does not move in 10 seconds, the buzzer of the device will trigger. The device will stop the alarm until the person does not enter the vicinity. The next part is the construction of the device. The construction of the device will start with a cardboard chassis. Using a cardboard, the researcher will make a box with 5 inches in length, 3 inches in width, and 1.5 inches in height. The front of the cardboard box will have cutouts for the spaces dedicated for the exposed materials for the ultrasonic sensor, lights, and buzzer. The chassis will be secured together with hot glue. after which a lanyard will be secured to the top of the box. After assembling the cardboard chassis comes the assembling of the electrical components. The electrical components will be following the circuit diagram as shown above. The next step is the programming of the device. The programming of the Arduino Uno will be using Arduino IDE software. After programming, the code will be uploaded to the device. Next is the testing and data gathering. The testing of the device will measure the accuracy of the device when detecting an object. The researcher will also test the effectiveness of the alarm and the duration of operating time of the device, after which will then be subjected in a survey that will determine the accuracy and legibility of the device. The said survey will compose of 10 individuals in the Barangay Bagumbayan, Bula, Camarines Sur. The next step is the statistic analysis. A Likert scale will be administered among the respondents to determine the end-user acceptability of the device. The end-user acceptability survey form of the device includes the device cost, portability, design, ease of use, marketability, and its relevance. The gathered data will be analyzed statistically through paired t-tests, which is used to determine if there is a significant difference between the means of two groups in a population from which the groups were sampled. Thank you for listening to my presentation.